Yes, yes. So we are discussing about microprocessor 8085. It is a processor we require to learn this micro about the microprocessor. So 8085. It is like it is used in this computers. Every computer run on microprocessor only. So what we are using the mobiles, smartphones, and everything, are robots or traffic signals and ovens, such as a toys, submissions, washing machines, all in industries. So the stepper motor, running of stepper motor, everything. So in many fields, we have used the microprocessor. It's the processor. So this processor nothing but is a mini computer. The 8085 processor is fabricated total. It will be IC, integrated circuit, fabricated on a single chip. Integrated circuit fabricated on a single chip, that is microprocessor 8085. Right. So what we're discussing in our study purpose in our course Ambedkar Open University, just we are studying in 8085 microprocessor. Right. So after that, advanced microprocessors also are available in our daily life. Advanced microprocessors. So what we are using the mobiles. So each mobile run on different features, new features. So everything is containing the advanced processors. Your processor is very very important. So when our human body is total controlled by our brain, same thing this processor. So controls processor having the control unit. It is a section of the CPU, central processing unit. Total it controls the processor controls all operations. Our brain controls all like operations of the body parts. Same thing, same thing. The processor also controls all operations. Right. So that's why it is technologies increases. Technology, well, advanced days are there. So that's why we must read, we must learn about processor. So here, actually, this processor, first of all, the Intel company, Intel introduced the the like processor after implementing like year by year. So new versions and advanced versions are there. First initiated by processor initiated by the Intel, right? Yes. So here, microprocessor containing mainly it has uh, mainly three parts. What are the three parts? ALU, arithmetic logic unit, and arithmetic logic unit, control unit, and timings and control unit, and next unit, what you call ALU, timing and control unit. Next, set of registers, mainly set of registers. So it has 40 pins. The IC of 8085 has 40 pins. 8085 has 40 pins. So this pin description I should explain in later other class, but it has 40. So 1 to 20, like 21 to 40. So 40 pins, 8085. And it is used a single 5 volts, like what is requirement of the power supply. 5 volts DC current it required, and it has Suppose it is supplied like the clock speed of this clock speed processor, it is 3 megahertz. 3 megahertz. This is the clock speed. Clock speed. It is a power supply. Power requirement is 5 volts for this. Next, it has total 80 instructions. 80 basic instructions. 80 basic instructions. 80 instructions. And 246 opcodes. 246 opcodes. So mainly it contains 3 parts. ALU, arithmetic logic unit, ALU, and next one is timing and control unit. Mainly it contains first one ALU, arithmetic logic unit, timing and control unit, timing and control unit. Next one, set of registers. Set of registers. Set of registers. So main parts. So arithmetic logic unit operates addition, subtraction, logic and logic or like logical XOR, like complement, increment, decrement, left shift to right shift to everything is operated in arithmetic logic unit performs. Arithmetic logic unit. Next, timing and control unit. Second one, timing and control unit. The timing and control unit is a section of the central processing unit. Central processing unit, it generates timing and control signals which are necessary for execution of instructions. It it controls the data flow between central processing unit and peripherals. It provides like status, control and timing signals which are required for the operation of memory and input-output devices. Here, timing and control unit. The timing and control unit, it controls the entire operations of the microprocessor and peripherals connected to it. Next, thus it is seen that the control unit of the CPU, central processing unit, acts as the brain of the computer system. Next one is set of registers. Set of registers. So here the set of registers here, the general purpose, these registers are used by the processor type temporary storage and manipulation of data and instructions. Data and instructions. Data remains in the registers till they are sent to the like memory or input-output devices. Intel 8085 microprocessor has the following registers: 8-bit accumulator register, and it will be connected to the it has 8-bit accumulator, 8-bit accumulator, 8-bit accumulator register, one 8-bit accumulator register. It is connected with ALU, arithmetic logic unit. Second one is 6 general purpose registers. 6 general purpose registers. 6 general purpose registers. And next, general purpose registers such as general purpose registers such as B, C, D, E, H, and H and L. These are the general purpose registers. So the general purpose registers are B, C, D, yes, B, C, D, E, H, and L. These are the general purpose registers and 8-bit registers, GPRs. Next, there are 16-bit stock pointer. Next to SP, the register sets. Next one is SP, stock pointer. And fourth one is program counter PC. And fifth one is instruction register. Next one is sixth one is a temporary registers. These are the set of registers. To hold these 16-bit registers, they have to maintain, like here, the data combined. Suppose if you need 16-bit, suppose these are the 8-bit registers. Whenever you need a 16-bit, the combination of 2 bits, 2 8-bit registers forms, the combination of 2 8-bit registers forms like the registers pair. Or the register pair are available here, BC, DE, and HL. These are the valid register pairs are in 8085. So 8085, the registers are 8-bit accumulator. Next, general purpose register 6, like B, C, D, E, H, and L. And SP, stock pointer, program counter, like instruction register, and temporary registers. Temporary registers. Whenever we need 16-bit register, so then the combination of 2 registers, the combination of 2 8-bit registers forms 16-bit register. Right. So what are the 16-bit registers are valid in 8085 microprocessor? That is the pair of BC pair and DE pair, and next one is HL. These 3 pairs are valid in 8085. Next, the HL pair is used to act as memory pointer, and for this purpose, it holds the 16-bit address of the memory location. So mainly among this pair, so HL pair, this HL pair acts as memory pointer, and for this purpose, it holds 16-bit address of the memory location. Whenever you need memory address, memory location, 16-bit memory address, we have to use HL pair. We have to use HL pair. So in addition to above like mentioned registers, the 8085 microprocessor contains a set of 5 flip-flop which serves as flags. 5 flip-flops of them. So which are serves as flags. A flag is a flip-flop which indicates some like addition microprocessor which arise after the execution of arithmetic or logic instructions. The 8085 microprocessor has like flags, carry flag, like CS, carry flag, parity flag, next to like auxiliary flag, carry flag, next to zero flag, and zero flag, and a sign flag. Sign flag. Total, it has 5 flags. It is a flip acting as a flip flap. Flip flop. Flip flop. So what 5 flags are there? So what are the flags are available here? First, carry flag. CS, carry flag. Next to parity flag. Next, it is auxiliary flag, auxiliary carry flag. Next one is a zero flag. Next to sign flag. These are the flags are available. So these are the set of registers. The set of registers, 8-bit accumulator, general purpose register 6, BCDE, H and L, and SP, stock pointer, program counter, instruction register, and next temporary register, and then Next, 16-bit pair of registers are available. So the pair, so combination of 8-bit register, two 8-bit registers forms 16-bit register. So above 16-bit registers are register pairs are available. Three are available in 8085 microprocessor: BC and DE pair, HL pair. Mainly HL pair used to it is used for memory address, memory locations, memory purpose, memory address. When we require memory allocation 16-bit, we have to use HL pair. In the program also we have to write HL pair. Right. Next, the additionally like 5 flags, 5 flip-flops are there. It is served as the flags. Thus, the 5 flags are like a carry flag. Flag is a carry flag. It is a carry flag. Next one is parity flag. Parity flag. Next, auxiliary flag. Auxiliary carry flag. Auxiliary carry flag. Zero flag. Next, sign flag. Sign flag. These are the flags. Okay. So 8085, like everything, the opcodes and operand, so it can understand whatever we give the information. The mission, the system can understand every information in binary system. The mission language, when we write the instructions, converts into assembly language, converts into mission language. The mission language in the form of binary system. So here, the EXA to binary. So everything data we have to observe, we have to display. Everything is displayed by the 8085. That is EXA. So what is the relation between EXA and binary? Right. Once again, to recall the purpose of this to understanding the lab activities and lab programs, and when we operate with, so it will be gives always in EXA result only. The result gives in EXA. So what is the byte and what is the like bit? So the consisting of the 8 bits, 8 bits are called byte. So bit or byte, bit is in the form of 0 or 1. It is a binary system. So this mission can understand in binary language, right? So what is the hexa and decimal? What is the relation between hexa and decimal? And next, what you call hexadecimal and binary system. Once you recall, so then everything, the information takes in the form of hexa and instruction word, the operand, opcode, and operands. So each instruction has two parts. One is like opcode and operands. So opcode, it shows the where it will be tasked. It's so that operand, the first part of instruction, and which specifies the task to be performed by the computer. A task to be performed. That is the opcode. Opcode, the first part of the opcode is it is performed by the computer is called opcode. Instruction first part is opcode. Second part is operand. The second part of the instruction is the data to be operated on, and it is called operand or like operand. The operand, what you call operand, gives in the instruction maybe in various forms such as 8-bit or 16-bit data, 8-bit or 16-bit address, like internal registers or memory location. So This is the brief introduction about 8085. 8085. Okay. Right now, next we are going to discuss instructions word, like instruction word size. So what is the instruction word size? What is the instruction word size?